In this video we're going to discuss CRA models for multiplying a fraction by a fraction. So we have two different types we're going to show. This first type is going to be fraction multiplication without subdivision. And then we'll show an example where we have it with subdivision. So the difference that we'll see here is that without subdivision, right, in this example we're starting with 6/8 as our size. When we have fraction multiplication without subdivision, it just means that these eighths can remain this size. They can stay as eighths. When we have subdivision, that means our original pieces will need to change to some other different size of part. Okay. So for this one, we have 6/8. So again, that second multiplier is our group size. So we have a size of 6/8. So we have six tiles that each take up 1/8 of this total length. And this full strip is taking up 6/8 of the length of this one hole. So we want 1/3 of this group. Okay. So since we have 6, right, 6 is a multiple of 3. So that means we can separate this into thirds without changing these sizes of parts. Okay, so I'm just going to create just a little bit gaps in here, just so we can see each group or each third of this total group. Okay, so from that 6/8, right, we want to first separate this into thirds, right, because that's our denominator of our leading multiplier there. So each of these is 1/3 of that full length of 6/8. Okay, and then looking at the numerator, I just want one of these thirds, one of these three groups. Okay, so with the concrete model, we can kind of move these ones away because we don't need those ones anymore. Okay, so this is showing 1/3 now of this full group of 6/8. So if I'm looking at what do I have, well, I have two equally sized parts. And what is the name or the size of those parts? Those are each 1/8. So I have 2/8. Okay, so that's a concrete model. That's a length model. In the other one, we'll look at an area model. And then for the representational model, I just have a number line here. So I have the starting amount of 6/8. Okay. And then again, I want to create thirds or create three equal groups. So I want lengths that have the exact same, or groups that have the exact same length. And I want to have three of these groups that are equal. Okay. So I can think of, I'll go to different colors here so we can have, this will be one group with a length of, this is one of the thirds of our total length of 6/8. This is another third of our total length of 6/8. And then this is another third. Okay. So we've separated this into thirds. Each third has a size of 2/8. And then again, looking at the numerator, I just want one of these thirds. So I just want this length right here. Right. You can pick any of them really, but so then we're not really looking at we're not including these necessarily. Okay, so that was that full group of 6/8. We divided this into thirds, into three equally sized groups, and then I just want one of those three groups. So I just want this one length here, and this runs from 0 to 2/8, so this has a length of 2/8 again. Okay. Again, we solve this not necessarily using the standard algorithm. So again, this would be our abstract model for this one. Okay, so that was our example without subdivision. And we'll look at an example with subdivision here. Okay, so we'll look at an area model for this one. We have 1/2 times 3/5. So our starting size, our group size, our starting amount against that second multiplier. So we have 3/5. So we have 3/5 of a whole shown over here in our concrete model. And I want 1/2 of this original amount here. Okay, so since I have three objects, right, there's no way I can create halves. I can't create two equally sized groups without changing the size of these parts. Okay, so I need to break these down into smaller pieces. Okay, so again, we need to kind of think of an equivalent fraction to this. We're not necessarily going to do that in the abstract model, but we're trying to think of, well, what are parts that we can break this down into that would allow us to create two equal groups. Okay. So we can think of breaking these into 2 equal parts, because we had an odd number of equal parts. So if we break each into 2, we're multiplying this into, or multiplying the numerator and denominator by 2 in this sense. Okay, because then we're creating an even number. We're creating 6. We're basically creating the equivalent fraction of having 6/10 modeled. Okay. Okay, so I've created the situation where I've changed this problem into 1/2 times 6/10. Now I have 6/10 shown. So, and again, I'm able to do that because those are equivalent fractions. I can see and verify that they're equivalent fractions because they take up the same area of the whole. So now that I have 6/10, I want 1/2 of this entire group, or you can think of it as taking 1/2 of each fifth. Right? So I could create 2 equal groups this way. Right, so this is 1/2 of this amount, right? These are equal halves. Or you could think of, right, taking away, right, just keeping half of each fifth. Okay, so either way we do this, right, we'll end up with 3 equal parts, okay, which is going to be our numerator. Right? We have 3 of those purple pieces, and then again, what's the size or the name of these purple pieces? Each of them takes up 1/10 of the area of this whole, so those are going to be tenths. Okay, so you can think of it as just taking, half of each of the fifths, right, when we're doing that throughout, so we're kind of partitioning each individual object. Or once we turn it into this equivalent fraction of 6/10, we can think of partitioning that whole group of 6/10 and can create 2 equal groups, and we're just going to keep half of this. Right, so we would think of taking these ones away. Right, we just want half of that group of 3/5. So there we partition this whole group of 6/10. So either way, we'll still have 3/10 left on the model. Okay. And then for the representational model, again, I have a circle with fifths drawn on here, and I've shaded 3 of these in. Again, I can't create 2 equal groups or take half of that total amount. So again, we need to think of subdividing this, and sometimes it can be helpful to subdivide this entire model just so we can see and verify our denominator. Okay, so again, now I have 6 parts out of the total 10 parts, so I have 6/10. And then if I want 3, or I want half of this group of 6/10, again, we could shade in these 3, or we could shade in, I'm going to shade in half of each, so we're taking a half of each fifth here with the red. Okay, so then if we're looking at what is the portion of the model that is shaded red, right, we have those 3 parts, and each of those parts is 1/10 of the whole. Okay, and then for this one, this could be our abstract model, right? Just this 1/2 times 3/5 equals 3/10. We could have also rewritten this as kind of an intermediary step, right? Rewriting that with that equivalent fraction that we actually showed in the models, and then showing that's equal to 3/10.